Right. A bridge up here. And let's start today's class by imagining what it was like when people first started building bridges. You know, you were here and then there was some water and you had to get over there. All right. My guess is they took a shot and tried some things and came up with something to cross over. Meanwhile, another village, maybe a few miles away, had the same situation. So they took a shot and came up with something. And it might not be very close to what the original group came up with, but it got the job done. Right? So each bridge built back then, I imagine, I'm not a historian or a civil engineer, but each bridge built there was kind of a custom job. It was built specifically for the situation, and you know what materials they used, what design they used was sort of a crapshoot. You know, they would come up with stuff that worked, but there was probably very little consistency between that. At some point, when this began being studied, and there were civil engineers and the like, they came up with some basic designs of bridges. 7 types of bridges every engineer should know about. Arch bridge, beam bridge, cantilever, cable, suspension, side arch, and truss bridges. We're just going to look at a couple of these because after all, we're not building bridges, we're building software, all right? But just to get the point. Arch bridges, these are arch bridges. There's a description of them. And they have advantages. High level of strength and resistance. Adapts to local environmental conditions. A greater span compared to beam bridges, though less than cantilever and suspension types. Can be constructed from different materials. And then some disadvantages. Beam bridges. Disadvantage is a limited span length. Cantilever bridges. Good for creating long spans. The point is an engineer would know all this stuff, right? And an engineer, if they were hired to build a bridge, if there needed to be a bridge on a highway or something like that, they would look at the circumstances and probably pick one of these 7 types. All right, because they know type A is good for this kind of situation, type B is good for that kind of situation, and so on down the line. So what started off as a custom craft, where everyone built their bridges their own way, and they did what they could to get the job done, and each new bridge was a brand new project, more or less starting from scratch. It's become more of an engineering job, whereas you know you have some tools and some components that you can use to create a solution to the problem that you're having. Now, I didn't live through the history of bridges. I'm not quite that old, but I have seen a good part of the history of software development, all right? And in a way, software development was like this. In the early days, everyone was hustling around, coming up with their own solutions to their own problems. People were writing custom code all over the place, and people took different approaches to solve similar problems. And there's some problems with that, right? If you take different approaches to save the same problems, if you bring in another person that worked at an organization, they may have to learn a whole different way of writing programs. There'd be no standardization of, if you have this problem, this is what you use. Unlike there is for bridges, where if you have this kind of situation, this is the bridge you use. Each thing, since it was custom, kind of had to be built from scratch, you know, kind of like having a suit made for you custom, as opposed to buying something off the rack, or buying something off the rack and having it altered to fit you. So because of that, people looked for sort of templates for their code that could be reused, just like these are templates for bridges that can be reused. And if you know the situation, I'll help you decide what template you want to use. Well, these templates in computing are called design patterns. Typical solutions to common problems. Each pattern is like a blueprint that you can customize to solve a design problem. Common language to help your team communicate more effectively and to help add new members to the team. If they're familiar with the models that you're using, they can integrate to the team faster. There are three groups of design patterns. We don't need to go into them in this detail. Here's a list of classic design patterns, again, that we're not going to, interestingly enough, there's a bridge and so on. There's software patterns, there's design patterns in software too, just as there's templates for different kinds of bridges. Now in this course, we have used, here's a design patterns example. This is just more of the same. In this course, we've used a design pattern known as, and it always takes me a second to get these letters right, MVVM. What does MVVM stand for? It stands for model, view, and view model. Let's think of how this applies, given, for example, of the restaurant page, let's say. Let's just look at meals to start, all right? There's a model, right? Meal.cs, that's your model. Actually, I'm going to rearrange these words. Even though this is called MVVM, I'm going to put the views in the third column. We then have an index CSS_HTML, a create.CSS_HTML. In other words, the views, the actual web page, the things that perform the user interface task, the thing that people actually see the data in. And we have, of course, when you scaffold, we have those 5 of them, I think it is. Details, edit, delete. All of these are based off of the meal model. And each of these has its own view model. And the view model is the .cs file associated with the page. Each one of these has so on. The view model is sort of the go-between between the model, which represents the data and maps to some database objects. User interface is the CSS that describes how the data is being displayed. And then we have the CS that sort of runs the show. All right, it's the boss, and it communicates things from, you know, it pulls stuff from the database and puts it in a form that the view can use to display the relevant data. So again, this is the model, view. Again, I just rearranged them. Now there's another way to do this if we were doing this another approach. And we'll talk in a minute about the respective advantages and disadvantages. There is what's called the MVC approach, which stands for model, view, controller. I don't really like the way that they're ordered, so I'll order them my own way. So you can see two of the words are the same, model and view. And those stay the same, right? If we were doing a meal project with this, we'd have our meal.cs. We'd have our index.cshtml. We'd have our create.cshtml. So on. CSHTML files. The difference is here we have one view model per view. Here we have one controller per model. So that's the difference in a nutshell between these two approaches. Still have the models, still have the views, but what's the go-between between the model and the view? Is there one for each page? That's a model view model or design pattern. If there's only one controller for the entire model, then it's the model view controller approach. Okay, and we can already guess at some of the advantages and disadvantages of this, right? In this case, we have a bunch of simple view models, right? Because a view model is only responsible for one page. So it's only responsible for the functionality that's relevant on that page. In this case, we have one big controller because it's responsible for all those views. So all the functionality on all those views is going to be handled by the controller. All right. So many simple, one complex. The other thing I would say is if there is functionality that gets repeated, in other words, there is functionality that exists, for example, on the create and the edit, creating dropdowns, for example. And if there's any other functionality that's duplicated between these pages, you have one place to put it and you don't have to duplicate it in each of the relevant view models. Let's see more of the respective advantages and disadvantages. This is an introduction to MVC. Talks about this. Clear separation of business logic, UI logic, and input logic. components, the disadvantages, and so on. If you've been taking a lot of the web development courses, which I assume both of you have had at least some of them, you see a common theme coming across, and that's separating things into different components. In basic web pages, you have the HTML and the CSS. Those are two separate things. This is sort of that same kind of thinking. You have the one set of operations in the model, one kind of stuff in the model, one in the view, one kinds of things in the view, and one kinds in the controller. When to choose one versus the other. They even throw in Blazor, which we're not going to discuss in this class. Blazor pages, of course, is the MVVM model. They don't use those words, but that's what it is because there's a page-based model. Razor Pages benefits: quickly build and update UI. Code for the page is kept within the page while keeping the UI and business logic concerns separate. So the UI is the view, the business logic is the .cs file. Testable and scales to large applications, keeps your content pages organized simpler than MVC. Advantages of MVC, the benefits. Mature and scalable model, clear separation of concerns. Separation of responsibility ensures the business model can evolve without being tightly coupled to the low level implementation details. Let's ask ChatGPT. Explain in simple terms perspective, advantages and disadvantages of MVC versus MVVM design patterns. Sure, I like that. It's happy to answer our question. Model view controller separation of concerns. It divides applications into three interconnected components. Independent development. Users can work on model view and controller separately, which speeds up development. It's easy to test. Disadvantages is it's more complex. For smaller applications, like probably the ones that we work on in class, MVC can introduce unnecessary complexity. The controller can become tightly coupled with the view, making changes more difficult. And MVC often requires more code to connect the components compared to simpler patterns. Data binding. Automatic synchronization between the view and view model. That may sound like, wow, we've never seen anything like that, but we have. Whenever you define a class level variable in the model, you're doing just that. In other words, you can define a list of categories, for example, on a page. And you could call it categories. On your UI, on the CSS page, you can say model.categories.something. All right. Or for each category in model.categories. And you can loop through those. That's what they mean by automatic synchronization. In other words, the model updates that variable is available in the view as well. Easier testing. The view model can be tested independent of the view, which simplifies it. Better for UI heavy applications. I would disagree with this. This actually is not a great answer, in my opinion. Understanding the concepts of binding and commands can be challenging for the newcomer. It's a lot easier than MVC, at least in my opinion. For simple applications, MVVM might introduce unnecessary complexity and overhead. Guess what? MVC is going to have even more of that stuff. Less control over UI. I would disagree with that as well. So I would say I would give this a C if I was grading ChatGPT today. All right, so let's get into the nuts and bolts of it. Your last lab is to complete the movies tutorial with using Model View Controller. So I'll probably do some of the coding in that, and I'll leave it for you to complete. So let's look at this tutorial and see what it wants us to do. Create a new project for Web Model View Controller. So let's do that. I agree with the grade you gave ChatGPT answer. Yeah, that was not its best moment, in my opinion. See, AI is not going to quite take over the world yet. Okay, we're going to create a new project. And we are going to pick this one. Call it something like movies. And we'll put it on the desktop. .NET 8.0, sure. No authentication. And let's create. Okay, notice it has a nice little folders for you: controllers, views, and models. Let's look at the next step after we've created that. Wants us to run it already, huh? Must have given us some default stuff. And I should have used the other browser. Oh, it didn't complain. All right, look familiar, huh? Starts off with the same default index file that we had in the other example. All righty. See what's next. All right. I'm going to add a controller. Controller is what takes the request and does something with it. Classes represent the models are the data,
The model classes use validation logic to enforce rules. The views are the UI, and the controller handles browser requests. It works with the model and calls the view template. So if we look at this, for example, look at this request, localhost : 5001, home privacy specifies the home controller and the privacy action. So there's a home controller. Privacy action. Right here. Doesn't do anything, it just returns a view. Our view, we have the privacy view. So it returns the privacy view. The index returns the index view. So when it says return view, that the name of the method, the name of the action is the name of the view that it calls. Okay. So we're going to create a controller. All right, it wants us to create a hello world controller. New scaffold item. Okay, okay, my bad. We pick over here. We want something for model view controller. We want a new controller, and we're going to make it empty. And what name do we want it to be? I think it tells us to call it Hello World Controller. Okay. And for the interest of time, I'm going to copy this code. Okay. Index is the default action. All it's doing is it's outputting, it's spitting that out. So that will appear on the browser. Welcome will appear if we call that, and so on. So we run this. one more of these. And we type in hello world, what's it going to do? Go as planned. Let's run this in the other browser and see if that's a problem. Oh, crap. Pasted the code in the wrong place. Goodness for undo. There we go. We type in hello world. It is going to call the index method and hello world controller and display this is my default action. How did it know that? Well, without any action, it's going to call the index. So if we don't specify hello world / something, it's going to call index. Now, if we wanted to say hello world welcome, we could do something like this. Then it displays the welcome action method. So if we get hello world, by default, it's going to pull the index. If we add anything for that, it's going to be looking for that. If we go and type something else, there is no goodbye. We get that the page can't be found. All right. We did all this. The routing format is set in the program.cs file if you're really interested. That's how it knows by default to call the index. You could change it to be something else, but you'd be probably foolish to do that. We could change welcome to accept an optional arguments that we could pass via the query string. Don't specify anything, it doesn't really care. If we do specify something, it will pull it from query string. By default, we don't put ID equals on the query string. Just this field is assumed to be the ID. And we've seen that before. I want to get through this last piece of adding a view. I'm going to, for the index of Hello World, I'm going to add a view. Change as no longer returns a string, it returns an iAction result. It's going to return a view. Now, what do you suppose the view is going to be called? It's going to be called index.cshtml. So I'm going to create a Hello World folder. My views. And then go in here and add page of view empty. And I'm going to call it index.cshtml. And I can put in there HTML code that I want to have. So just for fun, I'll put H1 that says hello world. So let's make sure we follow this. I go here, I'm going to type in slash hello world. What's that going to do? That's going to use the hello world controller. There's no operation after that. So what's it going to call? It's going to call the index operation. So we're going to call the index. What's it going to do? It's going to return the view. What's the name of the view? The name of the action, index.cshtml. Oh, I don't want welcome. And there's my hello world. All right. The one thing we didn't do is we didn't go and create the model. So we'll leave that part up to you. Now, you don't have to add actors like you did the first time we assigned the tutorial, but you will have to create a movie model and populate it and all that. And you'll create the views for that. Do notice one thing. Because this is a model view controller and not the MVVM, this CSS_HTML does not have a .cs associated with it. That code is in the controller itself. All right. That's all I had for today. This should be relatively straightforward. If you run into any problems, let me know. The last 2 weeks, next week, week 14 and week 15, during this time slot, I will be available for assistance on your project or in catching up if you have other labs that are due. I'll be in person in BU 210. I'll also be on WebEx at this location. And from 1 to 2, it's that office hours is dedicated just to this class, so you don't have to worry about running into someone from other classes. All right. I really want you to do a great job in the project. Remember to go beyond the defaults. Make it look different than the defaults. Add some things that you didn't get from strictly from scaffolding. Add some meaningful reports that take the raw data and put it together in a meaningful way that allows someone to do something useful for it. Are there any questions? Right. We will see you later. Thank you.